A turbocharger harnesses a vehicle's exhaust gases to compress fresh air, forcing that pressurized air into the engine's combustion chamber for a turbocharged performance. With it, a small engine can be as powerful as a larger one, using energy that would otherwise disappear out the tailpipe. The exhaust gas turbocharger is an invention that dates back over a century, but in recent years, the concept has literally been picking up speed. Design tweaks and the use of lighter materials mean a bigger boost to engine output, so a small engine can be as powerful as a larger one without guzzling extra fuel. Production begins at the foundry. An overhead sprayer blows sand into the shaped cavity of this box. The spraying action activates a binder applied to the sand. This causes a chemical reaction that solidifies the particles. The worker extracts the hardened sand shape from the box. The shape is called a core. It will be used to mold the inside of the turbocharger's housing. He files down any little bumps and rough edges. He then pipes adhesive around the border of a second sand mold and glues the first part to it to build up the core. He applies a putty-like compound to the seam to plug any gaps. Meanwhile, another worker uses a different technique to make smaller cores. He rocks the box, and this causes sand to flow into a shaped cavity. The sand has been mixed with heat-sensitive chemicals. He aims a flame at an opening in the box as burners warm it from the sides. This triggers a reaction that hardens the sand inside so it takes the shape of the cavity. The result is another smaller turbocharger core. These snail-shaped sand cores are now ready for casting. He places the cores in a mold which is also made of hardened sand. Machinery lifts the bottom half of the mold to the top half, essentially closing the mold. He pours molten aluminum into it, and it flows into the spaces between the cores and the outer mold. The aluminum solidifies in a minute, and the molds tumble onto a conveyor, revealing the cast turbocharger parts. They're connected by hardened flow lines. After separating the parts, they ship them to the turbocharger factory. Here, computerized tools carve and contour the aluminum part to specifications so precise they're measured in thousandths of a centimeter. This is the turbocharger housing before the work was done and after. Using a computerized probe, a technician looks for irregularities. Even minuscule ones will need to be fixed. It's now time to assemble all the parts. The worker inserts a bearing into one end of the iron center housing. He lubricates a second bearing and slots it into the other end. These bearings will ultimately support a shaft with a turbine on one end and a compressor on the other. He adds a metal collar and a third bearing to the assembly. He caps the bearing parts with a metal plate. It will keep lubricant from spilling out when the turbocharger spins. He flips the center housing around and installs a metal heat shield on the bottom. He inserts the shaft and turbine wheel assembly. He installs the compressor wheel on the other end of the shaft. He heats the wheel briefly, causing it to expand, which allows it to be pushed further down the shaft. Once cooled, it shrinks to the shaft for a tight fit. Next, a machine called a vibration sort rig spins the compressor at a high speed as a computer analyzes it for vibrations. Even the slightest tremor indicates an imbalance. The computer also detects the source of the problem so it can be fixed. He grinds the compressor nose ever so slightly to balance the part. He now nestles the compressor into the curled aluminum housing. It's a shape that's designed to funnel air into the engine. He secures the compressor to the housing with a metal ring. He fits the turbine end into its housing. It too has the distinctive curl to pipe the exhaust gases in the right direction. A blast of air now simulates the effect of those exhaust gases, spinning the turbine to power the compressor. It takes about 15 minutes to build one of these turbos. Once installed in an engine, it's full speed ahead.